Great seeing you here in our next video in our masterclass in project management. And in this video, I want to talk about the critical path method. Projects and critical path method are linked together, and it's a very interesting method, and every project manager should know about this. First of all, let's have a look at the background. Where does the critical path method come from? What is the critical path? How can we define or find the critical path? We look at the CPM, the critical path method, in 6 steps. We look at the individual steps, and first of all, we will at the end have an overview of the entire critical path method, how it was originally designed. So let's first have a look at the critical path method, the background of the critical path method. It was developed in the 1950s by Morgan Walker of DuPont and James Kelly of Remington Rand. At the same time, the US Navy developed the PERT method for their Polaris project. So basically, we have 2 methods that are being developed simultaneously by 2 different entities. The basis for the critical path method was laid during the Manhattan Project. The Manhattan Project was the project where the United States developed the first nuclear bomb. When we look at the different elements, PERT is an AOR method, and it's considering uncertainty. The critical path method can use an AON scheduling technique or an AOA scheduling technique with fixed duration estimate. So we can use it for different types of scheduling methods. It doesn't have to be an activity on the arrow or an activity on the node. First thing to do is about the critical path. And the critical path and method and the PERT were, developed at the same time. The name critical path was originally derived from the PERT method. So the PERT method gave the name critical path to the method that we are discussing. Now, the critical path is an important concept in project management, and the only definition of the critical path is that the critical path is the longest path through the network. There is at least one critical path, and all paths may be critical in the most extreme case. When we look at the result or the effect of the critical path, is that any change on the critical path will affect the project duration. It will become longer or shorter. And in some cases, even the critical path may change. But we will talk about that later in other videos and other lessons. First, let's have a look at the critical path in 6 steps. First of all, we have to specify each activity. Then we have to sequence the activity. So we have to draw a precedence diagram with this. That's the next step. So we sequence them. We draw the network diagram. We estimate activity durations. We identify the critical path. We do this by finding the longest path, and then we can update this path to show progress. Once we are working on the project itself, we can update the information. We will know when the activities start and finish, so we see how this path is in fact evolving. The first thing is to specify each activity. Once we know that a project has been approved, requirements and scope have been defined, we will decompose the project and we create the work breakdown structure until we reach the activity level. Each activity will be described in an activity sheet, providing all necessary information to create the corresponding deliverables. The next step is to sequence the activities. At the end of the decomposition, we have a list of activities which are linked to each other in a logical way. The next step is to identify their chronological order to determine the dependencies between the different activities. We will identify for each activity the predecessors and hence derive also their successors. The next step is to draw the network diagram. And based on the predecessor information, we can draw the network diagram linking all activities. Although the original CPM was based on the activity on the node, we have the precedence diagram method, we can also use the other methods, the activity on the arrow, to draw the network diagram, we may find a PERT or an ADM network. Both methods should provide the same result. Estimating the activity durations, when we look at the classical critical path method, the durations of the activities as set as fixed durations. In the PERT method, we have an expected duration and a standard deviation, and we calculated those using an optimistic, probable, and pessimistic duration. Now, today, the probabilistic approach has become more popular, and we can also use PERT durations without any problem. So we can use those estimations in our projects anyway. We will do it a little bit different, but it's very interesting to use this. The next step is to identify the critical path. Once the duration of all activities have been determined, we can calculate the start and the finish times of all the activities and find the project duration and identify the critical path. Here we're applying the forward pass, the backward pass, we're finding the float or the slack, and we have to be careful here because in many cases people look at the slack to determine the critical path, which is not necessarily a good solution. When we do the calculations, we first have the forward pass and we find the early start and the early finish. Then we have the backward pass where we find the late start and the late finish. Based on this, we can calculate the float or the slack, and we can find the critical path or the critical paths. The last element in the critical path method is to update the network to show progress. Once the final start and the finish times of the activities have been selected, we can use this as a scheduled baseline of the project. We can also represent it in the Gantt chart, but we also have that information in the precedence diagram. Start and finish times can be different from the original dates that we calculated, for example, the early start and the early finish times, because we have to resolve resource issues. We have to include slack reduction and other reasons. We will look at that later. When we are going to do the different calculations, we will see how we are going to adjust the start and the finish time to the actual situation of the schedule. When we look at the actual times, the actual start and finish times, we will see the progress, and we also have the estimate what is happening with the next activities, because knowing the actual times, we will adjust the start and finish time of the successors. We can put it, or like I said before, to the Gantt chart or to a bar chart, and we can use the information in earned value management. Certainly, when we have, for example, schedule information, we can use the earned value management method to calculate or determine the end duration or the expected duration or the expected end date of the project. So that's it for the critical path method. So that's it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.